Here a question is the absolute configuration of the following compound which was provided for us in the form of Fisher presentation is like this. Whereas in Fisher presentation it is present in a proper format, that is most oxidized group is presented at the top. So that is the original way of writing of the Fisher presentation. Hence this carbon is as per priority, first carbon, second, third and the fourth carbons. Hence it is having chiral centers at the second as well as the third positions. We have to fix the configuration at the second as well as the third place. Whereas to fix the configuration, if I go for the second center in the form of cross mark and third center in the form of cross mark, and if I give the priorities, OH gets the highest priority because that is oxygen. Whereas this C and C doesn't offers anything. This C is connected with Cl, implies this is second priority, this is third, followed by this is fourth. After joining 1, 2, 3, 1, 2, 3 results clockwise, but fourth is not present on the top or bottom. Hence it results as anti-clockwise, implies this is second carbon, this will be what? SC's configuration. Whereas if I go for the third, priority is behalf of, this will become priority number 1, whereas this is methyl, whereas this is connected with OH, this is priority 2, this is priority 3, this is priority 4. After combining all 1, 2, 3s, it offers anti-clockwise, but 4 is, that is reverse, so therefore opposite to that one clockwise. Clockwise implies at the third position the configuration is going to be what? R is the configuration. Hence the configuration of the given structures at the second as well as the third positions can be given by 2R followed by what? 2S followed by what? 3R. Hence the name of the compound is 2-hydroxy 3-chloro. Yes, 2S of hydroxy followed by 3R of chloro. Butanoic acid is the name of the compound. And another question is, we are asked to write the number of structural isomers of the formula, that is C6H14. C6H14 belongs to the category of CnH2n plus 2. Hence it is an alkane formula. So I can write 6 C6 plus 0 combination, 6 on the linear chain. In one way I can write. Whereas this is C of 6 plus 0 combination. I can write it as C of 5 plus 1 combination. That is C of 5 plus 1. 5 on the linear chain. 5 on the linear chain followed by 1 methyl may be present here. And there also we can write, that is 5 on the linear chain followed by 1 methyl is present here. Remaining 2 cases becomes the same. I can write it as 4 plus 2 combination, 4 on the linear chain followed by 2 methyls like this. Otherwise 4 on the linear chain followed by 2 methyls like this. In this way it is possible to write the total possible stereoisomers, total possible structural isomers. Structural isomer 1, structural isomer 2, this is 3 and this is 4 and this is 5. We are not counting any kind of stereo centers. Originally, to be say frank, this is one stereo center, here it is not a stereo center, but this is also not stereo center, this is also not stereo center, but this will become one stereo center, but we are not counting the stereoisomer. If I am just counting the structural isomers, the total number of structural isomers for this given formula will becomes 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5. 5 stereoisomers are present. How many are present? 5 stereoisomers are present. 5 not stereo, 5 structural isomers are present.